Hello and welcome to G Fun Facts Online. In a world of unseen threats, a unique brand of detective is at work. They don't dust for fingerprints or analyze blood spatter. The clues they uncover are much smaller, encoded in the very building blocks of matter. These are the atomic detectives of nuclear forensics, scientists on the front lines of global security, tasked with tracing the world's most dangerous materials. When nuclear or radioactive substances are lost, stolen, or used in a crime, these experts are called in to answer the critical questions. Where did this come from? When was it made? And who is responsible? Their work is a high-stakes blend of science and investigation, and it is crucial for keeping us all safe. So, how do they do it? It all starts with the nuclear fingerprint. Every single sample of nuclear material tells a story. Like a human fingerprint, each sample has a unique set of characteristics or signatures that can reveal its origin and history. Nuclear forensics is the science of reading these atomic signatures. The investigation often begins with what's called non-destructive analysis. Using techniques like gamma spectrometry, they can quickly identify the radioactive isotopes present, like specific types of uranium or plutonium, without ever touching the sample. This gives them a fast assessment of the threat. To delve deeper, they bring out an entire suite of sophisticated tools. Alpha spectrometry gives precise information about radioactive decay. Mass spectrometry measures the ratios of different isotopes with incredible accuracy, and this is a cornerstone of the field, because different production methods create distinct isotopic signatures. They even use powerful scanning electron microscopes to examine a material's physical shape, size, and texture for clues about its manufacturing process. One of the most fascinating parts of their work is called radiochronometry, which is the science of determining a material's age. You see, radioactive elements decay at a perfectly known rate, acting as a built-in clock. By measuring the abundance of certain isotopes and their decay products, scientists can calculate the last time the material was chemically purified. This age dating is a powerful tool that helps investigators narrow down the timeline of a crime. This isn't just lab theory. It has solved real-world cases. One of the most famous examples was the 1994 Munich plutonium seizure. Authorities at the airport intercepted plutonium smuggled on a flight from Moscow. Forensic analysis provided crucial information about its composition and likely origin, sparking fears about a post-Soviet nuclear black market. More recently, when a scrap metal shipment at the port of Rotterdam was found to contain uranium, a tiny sample was sent to Europe's atomic detectives. They identified a mix of different uranium types and, by analyzing its radioactive decay, determined it had been produced in the early 1960s. This incredible detail allowed them to narrow the potential origin to just 2 sites in Russia. The cases can also be bizarre. In Romania, authorities discovered playing cards contaminated with radioactive iodine-125, which were being used to cheat in a high-stakes card game. It was nuclear forensics that proved the illicit use of the material and identified the criminal group responsible. Because nuclear trafficking is a global problem, the solution must be international. The International Atomic Energy Agency, or IAEA, plays a central role, helping countries develop their own forensic capabilities and managing a database of trafficking incidents. This global network is vital for connecting the dots between crimes happening thousands of miles apart. The field of atomic detection is constantly evolving. Scientists are developing ways to get more information from ever smaller samples. Artificial intelligence is being used to analyze complex data and spot patterns a human might miss. Despite these advances, the work depends on strong collaboration between scientists, law enforcement, and policymakers. Nuclear forensics is a powerful, though often unseen, tool in the global effort to keep us safe. By reading the unique fingerprints left in these dangerous substances, the world's atomic detectives can trace them to their source, thwarting terrorism, securing materials, and bringing criminals to justice. Their work is an essential shield in an uncertain world.